This is the information that you have to share with your AI happy boss. Trust me, he's going to want to know this stuff. Governance starts with information. There are a lot of AI happy bosses out there that think AI slop is going to make their lives just so much easier. Make sure that they listen to this podcast. This may be a little bit longer of an episode, but actually, I'm probably going to cut this into two. What I do when I work with organizations and leaders, I give them a brief history about AI and how it works, which is important. And then I break it into how they can use it for their particular organization. And we can make some generalities in part two. So this will be part one. Leaders, before they get sold a product, should understand a bit more about the products that they are buying. We should know a brief history about how AI works-ish, the physical nature of AI, and what is good and what it's not so good at. And there are a lot of things that it's not so good at. Here is a bit of information that gives us some background so you can understand what AI is. Everybody throws around AI, but a lot of us don't understand what it is. So we're going to just go through just a few things, hopefully not in a boring way, and hopefully I'm explaining it to you in a simple enough way. If you are already deep within the AI community and you are an engineer programming weights onto your particular tool, I think this is probably not going to be the video for you. But if you are a person that is more of a normie, then I think this is going to be great. All right, here we go. Here's what you need to understand, or here's some information that you need to know when you're talking about AI. AI is just a term for building something that meets or exceeds human intelligence, which is the way our mind works is really incredible. And for us to be able to even come close to duplicating it is pretty awesome. A term that you may have heard before is machine learning, which is the ability to discover patterns in data. The more data that you give, the more confident it is in its responses. So if you think about it, let's say that you have 1, 2, 3, 1. This is a pattern, okay? Actually, we'll get into that in a little bit. So machine learning of discovering patterns. Deep learning is where it gets a little bit more tricky, and we're talking about neural networks, which you may have heard as well, which is using computers to simulate the human brain. There are many levels and a lot of complexity, maybe even unknown complexity to this. This piece comes into play later when we talk about what people are scared of. Foundational model, a model that takes in data and generates new content. It's as simple as that, and the new content and how it's shaped isn't the foundational model, it is the wrapper. So like ChatGPT or Grok or Gemini or Claude is a product shell on a foundational model, built on a foundational model. The tools that are very specific to an industry that you may use is also a shell on a foundational model. These shells are programmed to the specifications that a product owner would like. This is why, one of the reasons why, people are very wary of how products are trained. Perhaps you've heard that in the media. Janus Point, our sponsor, turn AI risk into defensible action. Janus Point is a Bloomberg-style decision platform. It's made for municipal AI governance. It brings together the most decision-relevant intelligence across policy, procurement, legal risk, peer city activity, and vendor oversight. It then turns that intelligence into practical workflows for due diligence, documentation, and performance tracking. The result is a clearer, more defensible way for city leaders to evaluate AI tools, manage risk, and of course, justify adoption. JanusPoint.com. How AI works-ish. Remember, this pod is for the masses, and things are being incredibly simplified. AI predicts what is going to happen next based on information it has. So let's use the numbers 1, 2, 3, 1. Okay, based on that information, if I said, okay, you have a 1, you have a 2, you have a 3, then you have a 1. what do you think is going to come next? Most likely, you may say a 2, right? Because what you've seen is 1, 2, 3, and then something repeats 1. The information you have, 2 would be next. Okay, now let's make it a little bit more complicated. This is going to be interesting. Bear with me here. What if you have 1, 2, 3, 1, 2, 3, 3, 1, 2? Well, that's more information. And now you may say the pattern's a little bit different. So if it goes 1, 2, 3, 1, 2, 3, and then another 3, it may go 1, 2, 3, 1, 2, 3, and then another 3. So in that scenario, you may say the next, if it's 1, 2, and every other time there's been 1, 2, there's been a 3, then you may say there's a 3. This is a prediction. It's not necessarily fact, but it's a prediction. The more information that you have to look at patterns, the more correct that you may be. Now, instead of this easy number-based example, AI is learning off of all the information in the world, kinda. It makes the predictions data huge. To be able to use these patterns to generate what we want, to tell the machine that is the right pattern most of the time, we assign weights to the probability of that being a good answer. Good being in air quotes here. These weights create biases towards certain answers to create two questions being right. So I'm using the term biases because that's exactly what you add weight. Hey, good job, or hey, this isn't right. The probability of it being a good job or right, I am suggesting that I am the observer saying that this is good and right. So you can see if you just extrapolate that, where that could be a problem. People adding weights and biases essentially determines what you see in the wrapper. What you see in an AI tool is a wrapper on top of a foundational model, like I said earlier. Specific tools are like specialists built on foundational models. Like, let's take doctors for an example. Doctors, you might go to the ear, nose, and throat, the ENT doctor, and that's a specialist, which is different from your family practitioner, which is going to have this broad understanding of things. Lastly, what you should also be noted is the information AI takes is in multimodal now. It isn't just text, it's video, images, and audio. Basically, it's capable of learning from the environment given the right tools to see and hear. So if it's got a video camera or audio, it can learn like us. Okay, next we're going to talk about the physical nature of AI. This topic is what's currently sparking fires in politics, so it's worth some time to break down because it's really the most talked about part of AI, which is a little bit insane to me because there's so many factors, but of course, because I'm in it every day, maybe I have a bias there. We will start with the elements and minerals that go into making the rare earths that go into making AI, whether it be chips or GPUs or data centers. There are more than 20 of these rare earths that are currently instrumental in creating these chips and processors for AI. Most of these rare earths come from limited mines. It's not like there's just a mine on every corner for lithium or high-grade silica. The majority of mining and refining is controlled by China. The high-end best, actually it's pretty much the best, makers of chips in the world come from Taiwan, which is another hotbed for politics. I'm sure you've heard, if you are paying attention to any global politics, China and Taiwan have an interesting relationship, and we do not want them to invade Taiwan. If you're wondering why, it is because of this reason. Nobody can duplicate what they're doing in Taiwan to make these chips. The best scientists and AI companies are American. This is a gross simplification, but currently both superpowers, I'm saying that we all have different pieces of this, and especially if you take China and the United States as superpowers, we currently kind of need each other. We are ahead on the tech and the building and in the programming, and they are ahead of controlling the minerals and all the physicality that needs to go into it. Additionally, everybody's having problems with data centers, which brings us to the next piece that we want to talk about. and that is the physicality of data centers. Is it data? Is it data? Nobody knows. This is the one of the hottest topics in politics. Sometimes I make myself laugh. Data centers are the physical space where AI foundational models are trained with information. These centers are mind-bendingly big, and they create a huge resource footprint. The amount of electricity used is quite staggering. Depending on the size of the centers, the amount of electricity can rival that of big cities. Just one data center is running as much as a big city. Projected energy use for data centers in 2028. By 2028, we are expected to go as high as 12% of all electrical uses is going to training AI. 12%. That is insane. Water. Water is currently used to cool these huge electricity using data centers. The amount of water is believed to be high, but honestly, getting the accurate data on how much water is used to cool these is pretty difficult. And after doing some research, I just genuinely don't feel horribly comfortable in saying that it goes through X, Y, or Z amount of water. There are other problems. The sound that emanates from them is a problem. The crappy deals for a little bit of tax money in these poor areas of cities, all sorts of other logistical reasons as to why it is consistently in local and federal news. By it, I mean data centers. Without these data centers, however, we will not be able to use AI on scale, which is what our economy is propped up on. It is quite the pickle that we have ourselves in. I think I'm going to end it here as far as the episode. This is going to be a 2-part series. The next part will be why it is important to understand these basics before you start to implement AI into your organization. Have a wonderful day, my friends.